Okay, this last concept here, reducing and enlarging compounded prescriptions. So sometimes in the pharmacy, you're going to have a formula that makes a certain amount, but maybe your patient doesn't need that much or they need more. So we're going to need to know how to adjust formulas to make the quantity that we need. So we can do this by using ratio and proportion. So let's take a look at these last examples on the lecture worksheet here. So this first one, we have a formula for an 8% ibuprofen gel. We need 8 grams of ibuprofen and 92 grams of base. We now need to write a new formula to make 30 grams. So the first thing I need to do here is figure out how much this recipe that I have is making in total. Well, 8 plus 92, that makes a total of 100 grams. So my formula that I have makes 100 grams. The formula I need to make should only make a total of 30 grams. So what we can do here is look at each ingredient separately. So with the ibuprofen, I know that there are 8 grams of ibuprofen in a total of 100 grams of cream or gel in this case. And my new formula should make a total of 30 grams. So if I solve for x here, and I need a total of 30 grams, the x is going to tell me how much of my ibuprofen I will need for this compound. So cross multiply and divide here. So 8 times 30 is 240, and then we're going to divide that by 100. So 240 divided by 100 gives me 2.4 grams of ibuprofen. So now, if I need 2.5 grams of ibuprofen, how do I determine how much base I need? Well, remember, your total minus your active will always give you your solvent. So in this case, I'm making a total of 30 grams. My active is 2.4 grams. So if I subtract those, that should give me my amount of solvent. So 30 minus 2.4 is 27.6 grams of base. So if I'm writing my formula, I'll just write this out better here. I would have ibuprofen, 2.4 grams, and base would be 27.6 grams. So that would be my formula now to make a total of 30 grams. Okay, so based on the example that we just went through to make 30 grams, I want you to do the same thing. So write a new formula to make 180 grams here. And then once you're done with that, you can move on to number 18. Okay, so number 18 says we have a formula. We have drug A, we're using 20 milligram tablets. We need 30 of them. Sterile water, 25 mils. Cherry flavor, 6 mils. And then we're going to QS to 120 mils with simple syrup. So we're going to add enough simple syrup to get us up to 120 mils. So this formula makes a total of 120 mils. So now we're going to write a new formula to make 6 ounces. So let's look. These are all volume units, so this would be 6 fluid ounces. So remember, 6 ounces, 1 ounce is equal to 30 mils. So 6 ounces, 6 times 30 would be 180 milliliters. So our formula only makes 120. We need to write a new formula to make 180. So let's take a look at each ingredient here separately. So here I need 30 tablets of drug A. So I know that 30 tablets of drug A is in a total of 120 milliliters. So to figure out how many tablets I need to make my new formula, I could just set this equal to X over my new total. So 30 times 80 divided by 120 gives me 45 tablets. So drug A, my new formula, I would need 45 tablets. So my 180 ml formula, I'll just write over here. So now I would like you to go ahead and do the same thing for these next three ingredients. So sterile water. We know that 25 mils are in 120 mils. We got to find out how much would be in 180. Then do the same thing with your cherry flavoring. Now, simple syrup. We can't determine how much simple syrup we will need here because we have tablets. We're going to crush those tablets up. They're going to dissolve and take up volume of their own. So in this formula here, when we get to simple syrup, we would say QS to our new total, which is 180. So QS to 180 with the simple syrup. So solve for the water and the cherry flavoring on your own here. And then these last three questions here, what's the final strength of the medication in milligrams per mil? So let's take a look at this. Remember, our active ingredient here is our drug A. And we know that in our formula that we're making, we're using 45 tablets of drug A. So if we're using 45 tablets, and each tablet has 20 milligrams, 45 times 20, that would be 900 milligrams of active ingredient here in our total of 180 mils of solution. So I have 900 milligrams in every 180 mils of solution. They're wanting the strength in milligrams per mil. So we need to reduce this down to milligrams per 1 mil. So you can either just divide this here, or you can set that equal to X over 1 mil to find your answer there. Now, this strength is going to be the same in either formula that we use. So you can see if we use this formula, we had 30 tabs that are 20 milligrams each. 30 times 20 is 600 milligrams. So we would have had 600 milligrams in 120 mils. So 600 milligrams in 120 mils. If you set that equal to X over 1 as well, your answer should be the same here. So X, if we take 900 divided by 180, that gives me 5. And then also if we take 600 divided by 120, that also gives me 5. So my strength is not going to change between formulas. I'm just adjusting the formula to make a new quantity here. So my strength in milligrams per mil would be 5 milligrams per milliliter. So now these last two questions are kind of a review for you. So what is the percentage strength and what is the ratio strength? By now, you should be able to determine those based on last week's lecture and what we've learned this week so far. So go ahead, complete those two questions, and then you should be ready to finish up the problems in the book. So practice problems E, you just have two questions there, number 2 and number 4. So by the end of this lecture, you should be able to finish this worksheet as well as finish the assignment in the book. So if you're still struggling with any of these concepts after you have completed all of that work, please let me know as soon as possible. Send me an email, shoot me a text, and comment on your workday if you need to, and we can get you some extra help.